In this exercise, we'll be looking at problems involving surface area and volume. We also have these exercises in the form of a booklet, so you can contact us to get the booklet so that you can attempt to do the questions on your own before you come and watch these revision videos to mark yourself with. Alright, let's continue with the question. We are told that a solid metal cone has a radius of 1.65 centimeters and a slant height of 4.70 centimeters. Number A says calculate the total surface area of the cone. We're also told that the curved surface area A of a cone with radius r and slant height L is A is equals to pi times radius times L. So remember, this is how a cone looks. It has a curved surface and then a circular bottom. And also, since we're told that this is a solid metal cone, we're told that it is solid. So we know that there's a curved part and then there's also a surface at the bottom or at the base, which is in the form of a circle. So in order to find the total surface area, we need to find the area of the curved part. Area of the curved part plus the area of the circle at the bottom. Area of the circular bottom. So this is what we'll use, put it in brackets, that is pi times r times L, which is the formula for the area of the curved part. And then to this we'll add pi r squared, which is the area of the circle at the bottom. So putting in the numbers, just put the pi value of the calculator and multiply this by the radius, which is 1.65, then multiply this by the slant height of 4.7. And then to this we'll add pi times radius squared, which is pi times 1.65 squared. So let's try to do this quickly on a calculator. So put everything in brackets. So we have open brackets and then pi times 1.65 times 4.7. Close the brackets and then put a plus sign, and then pi times 1.65 squared, 1.65 squared, like this. And then this is the answer that we will get. So remember, if you have an answer like this one which has many decimals or many numbers after the point, always write it to 3 significant figures. So the 9 is the third significant figure. So we'll write the answer as 32.9. Let me quickly correct this. This squared should be here. Alright, then let's move on to number B. So number B says find the angle the slant height makes with the base of the cone. So if I quickly draw a cone here, this is the center of the circle at the bottom, and then this would be the vertical height, h. That would be h. And then this is the radius, and then this would be the slant height. So since h is vertical and then the radius is horizontal, this will be a 90-degree angle. So if I draw this triangle on the side on its own, we have the 90-degree here, we have h here, we have the slant height, which is 4.7, and then the radius, which is 1.65. The radius is this one, and then there's the angle we're looking for. So this is a right angle triangle, so we can use the trigonometric ratios. So So a ratio which has a hypotenuse, this is a hypotenuse, that is the longest side or the side opposite to the 90-degree angle. And then this would be the adjacent side, the one with the 90-degree angle and the angle that we are looking for. So a ratio which has a hypotenuse and an adjacent side, it's cosine. So the cosine of this angle that we are looking for is equals to adjacent side, which is 1.65 over the hypotenuse, which is 4.7. So since we're looking for this angle, in order to find this angle, that's what we'll do. We'll say cosine inverse, then 1.65 divided by 4.7. And then let's quickly do this on the calculator. So on the calculator, here we have cosine, and then if we press shift or second function, for those of you who are using sharp calculators, then when you press second function and then cosine, it will display cosine inverse. So in this case, we'll press shift and then like that, and then it writes cosine inverse, and then it already has an open bracket, so we can just write in 1.65 inside and then divide that by 4.7 and then close the bracket. When you punch the equal sign, that's the answer we get. So remember, all angles are supposed to be written to one decimal place, so we'll write the answer as 69.4 degrees. So that will be our answer. Now let's go to number C. So for number C, Roman figure 1 of it, we are told to calculate the volume of the cone, and then we are also told the volume V of a cone with radius r and height h is V is equals to 1 over 3 times pi times radius squared times height. So we know the radius, we can use the pi value of the calculator, and then the h we don't have. But remember, we already had this triangle here. So in order to find this h, which is the vertical height, what we can do in this right angle triangle, we can use the Pythagoras rule to find this height. So remember, in the Pythagoras rule, the hypotenuse squared is equals to opposite squared plus adjacent squared. So what we have in this case, we have 4.7 as the hypotenuse, so we write 4.7 squared. And then we had identified this as the adjacent side, so the 1.65 we'll write 1.65 squared, we'll write it here. And then the h that we're looking for, it's actually the opposite side. So when we make h the subject, this is what we'll do. If we leave h only on the right of the equal sign, this 1.65 squared will take it to the left, and then it will be negative on the other side. So that's what we'll do. 4.7 squared minus 1.65 squared. So we had to put h squared here, also here as well. So you know that in order to remove the squared, we have to find the square root of both sides like this, so that this 2 cancels with the root sign. And then on the calculator, in order to find h, this should be in brackets. The whole of this should be in brackets, so that we can find h correctly. So let's do this quickly on a calculator. So you press the square root sign and then open the brackets and then write in 4.7 squared minus 1.65 squared, and then close the bracket. So when you do it like this, you are telling the calculator to work out what is inside the brackets first, and then it will then find the square root of the answer it will get after working these 2 out. So if we press the equal sign, that's the answer that we get. We can write this answer at least to 4 decimal places, because we're still going to use this h in our calculation when we try to calculate the volume. So don't round too early. If you have a value that you just calculated that you're going to use later in the calculations, write it at least to 4 decimal places, so that you don't reduce the accuracy of your answer too much. So this one, we can write it as 4.006. If you round at this 8, and then that's a 5, so we'll add 1 to the 8, so that will be 4.4009. So that will be 4.4009. That is the h. Now we can then find the volume, because we now have the h. So to find the volume, we'll say 1 over 3 times pi times the radius. Remember, the radius is 1.65, so that is 1.65 squared, then times 4.4009. So let's find the calculator and quickly do that one. So that is that's 1 over 3 times pi times 1.65 squared times 1.65 squared times 4.4009, and then we can press the equal sign. So as you can see, this answer is not exact. So whenever you get an answer which is not exact, write which is your final answer, write it to 3 significant figures. So this 5 is a third significant figure, so we'll write it as 12.5. That will be our answer. So the answer to all of this will be 12.5 cubic centimeters. Alright, let's move on to Roman figure 2 of number C. So we are told that a metal sphere with radius 5 centimeters is melted down to make cones identical to this one, the cone being talked about in the question. So we're told it's a metal sphere, so it's in the shape of a sphere. This is the radius, so it is melted down, and then it is then used to make identical cones to the cone that is being talked about in the question. So we're also told that, or what the question wants, calculate the number of complete identical cones that are made. Keyword here is complete identical cones that are made. So what we want to calculate is, after melting this sphere and then taking that liquid and then using it to make cones identical to this one, we want to find out how many complete cones we can make out of that molten sphere. So since we're going to use the molten sphere to make these cones, in order to find how many cones can be made, we have to divide the volume of the sphere. The volume of the sphere, we should divide it by the volume of each cone, the volume of the cone. So this is the formula for calculating the volume of the sphere. So put that in brackets. That is 4 over 3 times pi times radius cubed. The radius of the sphere is 5 centimeters. So we'll put 5 cubed here and then close the bracket. And then for the volume of the cone, we can use this one we've just calculated. So that is 12.5. So let's quickly do that on a calculator and see what we can find. So open the brackets, type in 4 over 3, then multiply that by pi, multiply that by 5 cubed. You can multiply that by 5 cubed. Type in the 5 and then write cubed. And then we can close the bracket there, like this. And then divide the whole of this by 12.5, which is the volume of the cone. So that's the answer that we get. Let's convert that to a decimal. So I will get, let me pull that up again. We get 41.8879 to 4 decimal places. That is 41.8879. So as you can see in this answer, remember these are this much cones. But then we're looking for complete cones. As you can see, we can only be able to make 41 complete cones, because the 0.8879 and so on cones, then they would not be complete cones. So the answer here is 41 cones. So this is the final answer, and this is all for this question. So make sure to watch the videos of the other exercises. All right.